Kalispera. Good afternoon. I'd like to thank you for inviting me today. Hopefully we'll cover some of the topics that were picked up on the round table that was just before I came on. So I'm going to talk to you today about the impact of e-cigarette flavorings and nicotine strength on an in vitro lung toxicity using a 3D constructed airway epithelium. I keep using this slide, and it keeps coming up over the past couple of days. So Public Health England, they're a big supporter of tobacco harm reduction, and as such, they've suggested that vaping may be more than 95% capable of reducing harm by more than 95%. And as such, they've recommended that consumers who would otherwise continue to smoke should switch to vaping as a safer alternative. So we wish to test this claim made by Public Health England in the context of vaping as it is today. So this claim was made now 7 years ago. One thing to consider going forward is the UK, certainly in respect to tobacco smoking, has been a reasonable success story. We're seeing a continual downturn in the number of smokers in the UK. We've seen quite an increase in the number of vaping, but it seems to be plateauing, which suggests that maybe there is not the gateway that everybody was concerned about. But it's crucial that the vaping products going forward have customer satisfaction. So that's about mouthfeel, that's about satisfying their need for nicotine, but it's also about providing good flavors for them to do so, which has obviously become a hot topic we heard in the previous talk with regard to Germany and banning flavors. It's also important to consider the third factor here, that tobacco-flavored vapor isn't the most popular. In fact, it's either a berry or probably even a mint flavor is the most popular. When looking at these products, so for this study, there's some important things to consider. So in terms of the stewardship of the products themselves, again, earlier we heard about popcorn lung, which is obviously the diacetyl compound in there, and anything under TPD, which is the European kind of control of vapor, make sure that isn't present in the e-liquids going forward. We've also got stewardship around production, using pharmacopoeia grade products, and in terms of manufacturing, in terms of the coils and wicks, in terms of what they contain, and batteries as well. That's something else that's been quite an important thing, not necessarily relevant to this, but it's important to consider good quality devices going forward. Then we've decided to use some high throughput methods to allow us to screen a large number of products going forward, which is worth keeping on top of to make sure you continually test your products. So I'll skip to the next slide, actually. So what we're doing here is we've got two different methods for assessment. So we've done an initial scanning approach using this equipment seen on the top left of your screen, which is a real-time cell analyzer. It measures cell index, which is a sort of surrogate marker for cell proliferation or cell death in its reverse form. And we decided to test effectively, because we're trying to test that claim of broadly of vapor being 95% reduction. We chose to test all the flavors we sell. And also, you'll see later on the nicotine ladder as well. So we'll look at the sort of matrix of nicotine and flavors. We also tested down the bottom here a base e-liquid flavor, so it's without flavoring, to see whether the flavoring could be shown to enhance the toxicity going forward. Then in the lower half, we then took a number of selected liquids forward into a whole aerosol exposure, which is a lower throughput, using a 3D model of human lung, so it's closer to the physiology of or the anatomy of the human lung, so it's a more relevant situation. That was done in whole aerosol rather than the initial screening approach, which is done with dilution of e-liquids into the culture media of the cells. So this was the phase one, so this is the flavor screening. So we literally put all the flavors into the real-time cell analyzer and looked at the cytotoxicity curve for them. So these are all at the same nicotine concentration, so they were all 18 mg per mil, which is the sort of standard top level of nicotine in the UK. And you can see here there's a sort of spread of cytotoxicities across from the different e-liquids, with the mints being slightly higher cytotoxicities than some of the other flavors. And we use these to go forward. So here we've ranked them based on their IC80 values, which is the concentration, which leads to a 20% reduction in viability. So this is considered to be the point of departure for each of these e-liquids. And you can see, as I said, the mints tend to rank slightly higher for cytotoxicity than some of the other flavours. So you can see on the right-hand column there, we've taken forward a few of the e-liquids. So we've taken peppermint tobacco, which has actually got a slightly higher EC50 value, which is why it was selected. It's also the most complex flavour, so it included the most ingredients. So that was also deemed to be a reason for taking that one forward. It's also the most popular flavour, I think, in the UK, but don't quote me on that. As a very berry, which was a berry is a kind of a group of flavours, so that was seen to be the most cytotoxic berry flavour. And then we've got a base formulation in there and a golden tobacco, which was sort of the tobacco flavour. So we've got a kind of range across the flavours and cytotoxicity profiles. As I said, this was put into, we used a Borgvolt LM4E to puff these, so we're doing for time 59 seconds, that's not very good, and compared them with 1R6F tobacco, and you can see that effectively in the whole aerosol exposure, the bottom axis has been curtailed, so it's actually further away than it looks. The 1R6F is on the far left. You can see that that's quite potent in its cytotoxicity, and these on the bottom axis is nicotine strength, so you can see you have to push the nicotine or the exposure through puffing, repeat puffing quite high on the e-liquids before you get close to toxicity. And in fact, only the peppermint tobacco showed cytotoxicity by whole aerosol in this 3D lung model. Here you go. You can see that we've then ranked these products by their IC80 values, and you can actually see that even with the cytotoxicity value of the peppermint tobacco being the most cytotoxic in this model, it still is actually greater than 95%, almost 96% reduced cytotoxicity with comparison to the 1R6F cigarette control. We're over. We also did a quick nicotine analysis curve, so I'll skim through this quickly, but we did 0, 8, and 34 nicotine products. You can see that they all group together and they're all done in the peppermint tobacco, the most cytotoxic, and they all group together. So fundamentally, you can see that the e-liquid flavours do not fundamentally increase the cytotoxicity impact of the vaping products in vitro when compared with cigarette smoke, and flavours demonstrated a greater than 95% reduction in cytotoxicity. The product testing standards are important to provide customer comfort for these products, and e-cigarette in vitro data must be appropriately analysed and contextualised to avoid misinterpretation of the data. An assessment of e-liquids alone is not sufficient to draw tangible risk-based conclusions.